Wait a minute. Okay. 8. There are 8 strictly convex deltahedra. First of all, what is a strictly convex deltahedron? Well, there's 3 words in this phrase, so let's look at each of these words one by one. First of all, what is a deltahedron? There's 2 bits in this word. There's delta and there's hedron. The word hedron is a suffix, and it's a suffix that's used to refer to 3D solids. Think of some of the 3D solids, you know, like decahedron or tetrahedron, or even the word rhombohedron, which refers to a 3D shape whose sides are all rhombuses. So what about delta? Delta refers to one of the Greek letters that looks a bit like this. This is the small delta, which sort of looks like a D, but the big delta, which is what we're interested in, has a shape of a triangle. So thinking along the lines of rhombohedron, the deltahedron will be a 3D shape which has got faces of a triangle, or faces like the letter delta. And not just any old triangle. For deltahedron, we're talking about faces that are equilateral triangles. So what about the next word, the word convex? What does it mean if a deltahedron is convex? So first I'll explain what convex means with 2D shapes, and then we can just extend that idea on for 3D shapes. Say I have a shape like this, which is a convex shape. If I put 2 points on 2 different sides of this shape, and I draw a line connecting those 2 points, this line drawn will not leave the actual shape. And if I can say this for all pairs of points on the sides of this shape, and then this shape will be convex. Alternatively, if I have a shape looking a bit like this, and I have 2 points here, and I try to connect these 2 points, you can see that this bit of the line that actually leaves this shape. This means that this shape is non-convex. And this idea also extends to 3D polyhedrons, 3D shapes. If I have a 3D shape which is convex, and I put 2 dots on 2 different sides of that shape, and I connect it with a line, that line will never leave the polyhedron. For example, a cube will be a convex polyhedron because I can put 2 dots on any of the 2 sides connected, and that line will always stay inside of the cube. It will never leave the cube. So convex deltahedron would just be deltahedrons, 3D shapes which has got equilateral triangles at sides, which is also convex. Now what about the strictly bit? Now the word strictly is really used to describe the actual deltahedron more. If you have a shape looking a bit like this, well, all of its sides in fact are equilateral triangles, so they're sort of a deltahedron. Except that this bit here, even though it's made up of 6 equilateral triangles, all these sides are really on the same plane and connected to each other. And while you could think of it as 6 equilateral triangle sides, it's really more like one single hexagonal side. So if a shape is strictly a deltahedron, this won't exist. There will be no adjacent sides which are on the same plane as each other. So this shape, while it is a deltahedron, it's not strictly a deltahedron. And so those are the 3 words described. So in order for any solid to be considered as a strictly convex deltahedron, it must follow all of these 3 things that I've mentioned earlier. And so with these 3 criteria, there are 8 different strictly convex deltahedra, which are the tetrahedron, the octahedron, the icosahedron, the triangular bipyramid, the pentagonal bipyramid, the snubdisphenoid, the triaugmented triangular prism, and the gyroelongated square bipyramid. I personally think that last shape has a really cool name. Well, isn't that neat? There are 8 strictly convex deltahedra.